Okay, before we even get started with question 10, I just want to do a little bit of revision just to make sure you fully understand what factorials are, because we're going to need to know. So, n factorial means n times n minus 1 times n minus 2 times n minus 3 all the way down to times 1 at the end. So n minus 1 factorial means n minus 1 times n minus 2 times n minus 3 times n minus 4 all the way down to times 1 at the end. So notice that n minus 1 factorial is part of n factorial. So all of this here is n minus 1 factorial. So we could say that n factorial is n times n minus 1 factorial. Now we could also say that n minus 1 factorial, well, after the n minus 1, we've got n minus 2 times n minus 3 times n minus 4 all the way down to 1. So we could say that n minus 1 factorial is n minus 1 times n minus 2 factorial. We could even say that n factorial is n times n minus 1 times n minus 2 factorial. So hopefully you're all happy with this kind of idea, because we're going to be using it for this monster of a question. Okay, here it is then. So 5 marks. In the binomial expansion of 1 plus x to the power of n, where n is greater than or equal to 4, the coefficient of x to the power 4 is 1.5 times the sum of the coefficients of x squared and x cubed. Find the value of n. Cool. So, if we check out the formula for binomial expansion, here it is from the formula book, we can see that the coefficient of x to the power 4 would be n choose 4, x cubed would be n choose 3, and x squared would be n choose 2. So what we can say then is that n choose 4 is 1.5, which is 3 halves, n choose 3 and n choose 2. Now if we look at the definitions again, we can see that n choose r is n factorial over r factorial times n minus r factorial. So we're going to convert each of these terms into their factorial form. So n choose 4 is n factorial over 4 factorial, which is 4 times 3 times 2 times 1, so that's 24, times n minus 4 factorial. Now this is equal to 3/2 n factorial over 3 factorial, 3 times 2 times 1, which is 6, times n minus 3 factorial, add n factorial over 2 factorial, so 2 times 1, which is 2, lots of n minus 2 factorial. So this is what we now want to solve for n. So what we really need to do is get rid of all of the factorials. So how are we going to do that? Well, first of all, we're going to rewrite the n factorial terms. Now this is where what we did at the start is really going to help us. So let's do each term. So n factorial we can think of as n times n minus 1 times n minus 2 times n minus 3 times n minus 4 factorial. So that's what we have over on the left. Now that is equal to 3/2. Now with this first one, we've got n times n minus 1 times n minus 2 times n minus 3 factorial over 6 lots of n minus 3 factorial, and then the last term is going to be n times n minus 1 times n minus 2 factorial over 2 lots n minus 2 factorial. Now that might look horrible, but actually it now allows us to get rid of all the factorials. So on the left we have a common factor of n minus 4 factorial. In the first fraction on the right we have n minus 3 factorial, and on the last term we've got n minus 2 factorial. So we can clear this up a lot. So over on the left, the n minus 4 factorials cancel. We get left with n times n minus 1 times n minus 2 times n minus 3 over 24 is equal to 3/2. So here we've got n times n minus 1 times n minus 2 the n minus 3 factorials cancel, so then we just got 6 on the bottom, and then the third term is just going to be n times n minus 1 over 2. Okay, so it's starting to look a little bit nicer. All of our factorials have gone, so that's definitely good. Now then, do we have any more common factors that we can cancel out? The answer is yes. All 3 fractions up on top have an n times n minus 1. So we can divide through by n times n minus 1. So that's going to leave us with n minus 2 times n minus 3 over 24 is equal to 3 halves times n minus 2 over 6 and just 1 half. So that is starting to look considerably nicer. I'm going to clear things up. Okay, next up then, let's start sorting out these numbers. So, if I multiply through by 24, I'm going to get n minus 2 times n minus 3 is equal to, now 24 times 3 halves is 72 divided by 2, 36. So I'm going to get 36 lots of n minus 2 over 6 and 1 half. So we've got n minus 2 times n minus 3 is equal to, well, 36 lots of n minus 2 over 6 is 6 lots n minus 2, and then 36 and a half is 18. So, finally, at this point, we are now down to solving a quadratic equation. So, if we expand on the left, we've got n squared minus 5n add 6. On the right, we've got 6n minus 12 add 18. Now minus 12 add 18 is positive 6. So, as with all quadratics, get everything on the same side. So, subtract 6x. That gives us minus 11. Sorry, 6n, no x. That's going to give us minus 11n. And then, if we subtract 6 from both sides, they both cancel out. So we're left with n squared minus 11n is equal to 0. Factorise this. N times n minus 11 is equal to 0. So n is either equal to 0 or 11. Now, in terms of the question, we're doing a binomial expansion, and we were told that n is greater than or equal to 4 anyway. So the only answer is n equals 11. Good times. What a ridiculous question for AS level. Jesus.